exactly I'm trying to do here. Everybody knows that digital image processing is uh, something like hot in technology, and there has been enormous changes the day we started shifting from analog processing to digital processing. So today we're going to talk about not about much about digital signal processing, but about digital image processing. And our focus is not to get into digital image processing, but the focus is on how to use Python and its libraries to do a digital image processing. So first and foremost is that we are going to explore what are the libraries, by which from Python by which we can open just a image. So let me show first the image what we are talking about. The image is here. This is some image which we have made. I'm just trying to make an image explaining the concepts of umbrella fund and all, which is the fund world, which is a separate topic. I'm not going to talk on that. But what we are doing here is that we are trying to open the image using OpenCV library, which is a very good package in Python. And then we're going to use NumPy to plot the library. We are going to use the NumPy to make a histogram first. And then we're going to plot that histogram using the matplotlib. So these are the things which we are going to do. We're going to first import the library OpenCV for image processing. We're going to use NumPy, to plot a histogram, to make a histogram. Sorry. Then we're going to use matplotlib to pictorially plot the library. And let me explain a little of what exactly. So this is my first session on digital image processing, but rather than explaining basics of digital image processing, I want to get directly to using Python. And as we code, I'm going to explain the concepts also of digital image processing. But today, what we are going to do here, we are simply trying to make a histogram of a JPG image. The first command is going to read the image. The second command is going to draw a histogram. We're going to flatten the image, and we are going to you can see that there are two outputs. One is the histogram, and then other is pins. So histograms, using histograms, we would get a plot like this, which you see in the right? And then we have CDF, which is the blue line, normalized CDF. So we plot a histogram by using the NumPy library. We give this arguments for NumPy. NumPy generally takes array of objects, right? And then we are able to force mathematical operations over arrays, right? And NumPy.histogram, it is the first argument is the type of image you want. You want a flattened image, and then the second one is giving the number of arrays, 256, and then the scope which we are getting 0 to 256. Second one is the CDF, and CDF talks more about the blue line, what you see, right? Then we are giving a color for this. For the CDF as a blue, And for the histogram, we are giving the color as red. And then we are giving the limit here, X limit for plotting the graph. And then we are going to also, give a legend here. The legend will say CDF histogram, and the legend is on the left side. So this is it about today's class. But digital image processing, I'm going to tell you further, but before that, I want to give you some introduction of, what exactly we talk of a digital image processing. The easiest way to get started on digital image processing is, is this one. This is the one I wanted to talk about. You see this poster. This one, let me save this image. And then let me open this. So this is about, a movie, a Bollywood movie, where we have done a handwritten poster. This is a handwritten poster. That means some artist has done this. If you see this, even this is also a handwritten poster. It's not the actual poster, right? How exactly they do this? See, this is a pose of this person, Mr. Amitabh Bachchan running, and then the poster also says about something about, if I would take this poster, if I want to draw somebody's drawing, right? Let's take Amitabh Bachchan. I want his when he was young, right? So how did he look during the time? Amitabh Bachchan, Don. Let's go to this images here. And suppose I want to draw this one, right? I want to draw this pose of a figure, or maybe this one. So what I do is I do take a snapshot of this, and then I'll go to paint. Put this figure here, right? Now the next thing what I do is that since I want to draw this, to make my drawing easy, I simply put the lines here. This is my first line, my second line, my third line, my fourth line, my fifth line. And this is my first column. This is my second column. This is my third column. My fourth column. And this is my fifth column. Now, the artist, what he's going to do is he's going to just paint each of these squares, right? And when he paints this each of these squares, he's going to assemble this. And that's when he assembles this, he gets something like what we are talking about this test. This is the So this is the way the painting was done in earlier days, rather than making a poster. But Why are we learning this? That's a question, right? What is the relevance of this with the subject what I'm talking? So the artist made the squares, but we, if we want to capture this image and display on something like electronic media, let's say our television, right? The television is nothing but its display is a monitor which has the pixels. 1, 2, 3, 4. You know, this keeps on going. And then it is having all these pixels. TV is having these pixels. Each pixel is going to carry some information. So this is the colors what we have. And then it is going to have an intensity and a contrast. So all that information is spread here, and that each display is just like a LCD display is going to display the image, right? So this concept of pixels comes here, right? In digital image processing, we need to understand first what are pixels. And it's all game of pixels, digital image processing. Let's come back to our program now. And then what we did is we opened an image and then we try to make a histogram. Why should we make a histogram? That's the question, which we'll deal next. And we'll do plotting also. So histogram plays a lot of importance when it comes to putting the what you call as thresholds to differentiate objects when we do image processing. But for now, this is what I want to say, and I'm going to stop here.